everyone, I hope you guys are all going great. Today we're going to talk about fractals. But before, we must figure out what is a fractal. A fractal is a concept used in geometry. As simple as it might sound, a fractal is a never-ending pattern that is created by repeating a simple process over and over again. It can be a shape, for example, that is repeated many times using smaller dimensions. The different scales used are therefore what we call self-similar. A coach snowflake, which is a snowflake like this one, is a great example of a fractal. First, we start by making a triangle. Then, to each side of the triangle, we add smaller triangles, which creates step 1. Then, we add to each side of each triangle, we then add smaller triangles again, which creates step 2. Then, we can repeat it many times, for example in step 3 and in step 4, until we create a coach snowflake. Consequently, fractals are things that might seem very chaotic at first, but are actually pretty ordered. As you'll see later on, a fractal can be seen in many different objects.
So within the idea of fractals comes the idea of self-similarity. So self-similarity is sort of an extra component that is used to define what fractals are. And self-similarity itself is thought of as objects that become self-similar when similarity is seen within the general object. So basically that's sort of like a general idea of it, but in reality it's more like the more you zoom in or the more you zoom out of an object, the more that you can see the same patterns and the object looks just very like similar in a way. So I'm just going to show you a couple of examples of fractals here. I'm going to go quite quick because fractals sort of explain themselves through the pictures. So this is a broccoli, and it's an example of a fractal. So as you zoom into the broccoli, the more that you'll see that the same pattern is seen, which is sort of the definition of a fractal here. So we can see that there's different bumps, and within the bumps are more bumps basically. Another example can be lungs. So lungs right here, the more that you zoom into them, the more that you'll see the same pattern. So here you'll see little branches are seen, and the more that you zoom into the little branches, the more that there are even more branches. Another example can be trees, which is very similar to lungs, so branches within branches. And there's also a peacock, which I thought was really interesting. So the same patterns are seen throughout the tail of the peacock, and the more that you zoom in or zoom out, the more that you can see them.
So an example that could explain fractals is the Mandelbrot set. So the Mandelbrot is the use of computer graphics to display fractal images. So as we zoom in into this blob, we can see that it's infinitively deep and complex with infinite repetition and infinite variety. So images can be created by applying this equation in a repetitive process, and by which c is the constant. So z equals z squared plus c. You add a small number, you square it, and then you add the constant, and the result of that, you add it back into your z, square it, add your c, and you continue and continue and continue doing that. So this could be an example. So you have your c, you add it into your z and your c, you square it, you add it, the result back into the other equations after. What comes out of it can sometimes give you marvels like this blob. So it looks like a big blob with patterns extending from it, but as we zoom in more and more, we can see that this pattern is repeating itself in a never-ending way. So you can see some similarities and patterns as you zoom in, but it's never-ending and it's infinite as you zoom in. Different colors, different patterns, but in the end it all comes down into this big blob. So this proves that chaos has a degree of order. So fractals seems so complicated, but in the end it has somewhat of an order.
Movies and fractals. Bernard Mandelbrot's TED Talk. What good is that to know these things? Well, surprisingly enough, it's good in many ways. To begin with, artificial landscapes, which I invented sort of, are used in cinema all the time. We see mountains in the distance. They may be mountains, but they may be just formula, just cranked on. Now it's very easy to do. It used to be very time consuming, but now it's nothing. Now, look at that. This is an example of the Sierpinski triangle evolution, in which we can see fractals going from this triangle to this one in the end because of the repetition. And here is an other example based from the previous example, which is the twisted Sierpinski gasket, in which we twisted the previous fractal, and we need to distinguish if this mountain is fake or real. And so one of these are made by using fractals. So this is an example from Star Trek.